Okay, if the question is to obtain the semantic rules, to obtain the semantic rules to construct a syntax tree, to construct a syntax tree for simple arithmetic expressions with operators minus, plus, star, and division using top down approach. Okay, whenever they have asked for top down approach, you will get to know that you have to eliminate the left recursion and left factoring and all, correct? So for general arithmetic expression, you know the grammar. What is the grammar? E tends to e plus t or e minus t or t tends to t star f, t divided by f, or f tends to within the braces e digit or id. Yes or no? So now you convert this it into the top down grammar. Top down approach grammar means you have to eliminate left recursion. After eliminating left recursion, you are very used to it. This you know that the steps for eliminating the left recursion. What will be the grammar after eliminating left recursion? E tends to t dash, e dash tends to plus t dash minus t dash or epsilon, t tends to ft dash, t dash tends to star, ft dash division ft dash or epsilon, f tends to e digit id. Okay, now whenever they have asked for top down approach, first you have to consider this, and after eliminating left recursion you will get this one. So now you have to use this in order to construct a parse tree, annotated parse tree, or it may be syntax tree. Okay, now you have to, they'll not give any grammar, you have to consider this, and directly if you consider the left recurse grammar, then also it's fine. Okay, so now they are asking to write the semantic rules to construct the syntax tree. What is the difference between syntax tree and parse tree? In parse tree, we will write in one node. Here, each node in syntax tree consists of three things. Okay, first one is the operator, second one is the child nodes, okay, which it uses, and you have to specify the attributes also. Okay, because annotated parse tree means what? They, when you specify the attributes for each non-terminal, then it becomes what? Annotated parse tree. Okay, but here we'll represent it in different form. See, while writing syntax tree, you have to remember, you'll use, the difference is you'll use two functions. One is leaf and another one is node. Whenever you are creating a leaf node, then you'll use this function. Whenever you are creating a node, you'll use node function. Okay, so now while generating the syntax tree, we'll write the semantic rules also. Okay, now the grammar we have is e tends to t e dash, and e dash tends to plus t e dash minus t e dash or epsilon, t tends to ft dash, t dash tends to star, ft dash division ft dash or epsilon, f tends to within the braces digit or id. Okay, now one by one we'll write. Okay, so now see, first production you consider, what will be the semantic rule? See, e tends to t e dash. If they have given this, now if you have assumed, see, in order to understand the difference between the synthesized and inherited attributes and writing the semantic rule, I am giving an example, I am taking an example. Later I'll directly write the semantic rules. Okay, so if I have, see, 3 plus 6, how to write the annotated parse tree with respect to top down approach? See, Here I have t dash. Okay, what operator I need? Plus. So which production you will consider? You will consider this production. I will extend e dash tends to plus t e dash. Now what lexical analyzer does, it associates the value directly. See, it associate 3 here and it associate 6 here, because only these two are deriving for digit. Yes or no? Now this 3 is associated to this f. Okay, f dot val. Now t dot val will be having 3. Now in order to perform this plus operation, you need two operands. Okay, where are the two operands? One operand is its parent and one operand is its sibling. So now you have f will be 10 to 6 and t will be 10 to 6. Okay, not a problem. But now I have t to 6, but I want e value also. Where is that value? That value means this 3 is with t. I have to pass it to its sibling. Whenever I pass the attribute value to its sibling, then there the attribute becomes what? Inherited. Now e dash is having which type of attribute? Inherited. And what value it holds? It holds 3. Okay, now you have 3 here plus 6 here. Now we have to perform the addition operation and store it into e dash. As it is evaluated, the value for this attribute is evaluated from its parent and the sibling. 3 plus 6, yes or no, in this direction. 3 plus 6 is 9. It is evaluated through its parent and sibling. So what attribute it becomes? Inherited. Okay, what the value will be? 9. Okay, now this value which should be passed to, as we have to send it to the root node. Okay, we have to pass it to the upper node. So now when I am taking this 9 value, this e dash has synthesized attribute also. Now e dash, if you pass it to e, then this also will be having synthesized attribute and holds the value 9. Okay, this how, okay, we'll get inherited and synthesized attribute. It is very simple. Whenever we evaluate the value of attribute, okay, from its parent or sibling, then it is called as inherited attribute. Whenever we are evaluating the value of attribute from its child node, then it is called as synthesized attribute. Now with respect to this, we have to write for all the operators. What is the difference when we are writing the syntax tree? The only difference is here we have to make use of leaf and node functions. Okay, one by one we will write. Okay, when I consider the first production, e tends to t e dash, what happens here in this production? What I did previously, see, t value I passed it to e. Yes or no? Now t dot node, this is synthesized attribute. I am passing the value to its sibling, so it becomes what? Inherited. So that semantic rule I will write here. Okay, what is that? T dot node, pass it into e dash dot inherited. Got it? Now e dash dot, now as I have to pass it into the root node, this e dash also contains synthesized attribute, because this value what I'll get here after getting from t dot node, that I have to pass it to e, then it becomes synthesized attribute. So e dash dot synthesize is equals to e dot node. Hope you understood this particular step. Next I'll take e dash tends to plus t e dash. Whenever I'll get e dash tends to plus t e dash, in order to differentiate with respect to LHS e dash and RHS e dash, I'll make this as e1. Okay, that is the main reason. Now e dash dot inherited, see, I have e dash here, so I have plus t e dash. Yes or no? Now you are creating a new node. Which is that new node? This one is the new node. How we are getting? By performing plus operation to e dash and t. Yes or no? In this direction you will be getting. So I'll write here e dash dot e1 dash dot inherited is equals to I am getting new node. Okay, why, what is the value of that node after performing plus operation? For what values? E dash dot inherited and t dot node. Yes or no? This is t dot node, then e dot d dash dot inherited. These two value I am adding and getting to e dash new node. Got it? Why this is inherited? Because from t dot node it has taken the value, so it is inherited. This inherited and this node adding together I am getting the value for e dash. So that I have written here. Hope you followed. Next, after evaluating once again, after evaluating e dash tends to plus t e dash, after evaluating I'll get the value to e dash. Now I have to again pass it to e dash. This e dash again becomes what? Synthesized, and this will be passed to the above synthesized node. So what I'll write, e1 dash dot synthesized is equals to e dash dot synthesized. Okay, hope it is clear. In the similar way, we'll write the semantic rules for all other. Okay, for example, e dash tends to minus t e dash. Now what happens? Tell me. I'm getting new node after performing minus. So new node of minus, right, e1 e dash dot inherited, and what value you will take? T dot node. Between these two you will perform. Yes or no? See, e dash tends to minus t e dash. If I have, I will perform. E dash will be having one value and t dot node will be having 3. So now I will perform negative operation for these two. 4 minus 3 is what? 1 should be associated to here. As this value, this non-terminals attribute is evaluated from its parent and its sibling. Therefore, this becomes what? Inherited attribute. So I have specified here e dash dot inherited. Hope it is clear for everybody. Okay, so next. So here again that value I have to pass it to the parent. So e1 dash dot synthesized is equals to e dash dot synthesized. Okay, next, e dash dot tends to epsilon. If I have e dash tends to epsilon, then value doesn't change. The same thing I have to pass it to the root node. So inherited, what I'll be having, the same thing I'll pass to the synthesized node. Okay, to itself, right? So for that, e1 dash dot inherited, sorry, e1 dash dot inherited, I have to pass it to e dash dot synthesis. Similarly, do it for t tends to ft dash. Okay, t tends to ft dash means what? F dot node I have, that I have to pass it to t dash. T dash becomes what? Inherited. Why? Because this f is sibling to t dash. As the value is taken from f to t dash, that is from sibling, this t dash becomes what? Inherited attribute. Means it holds inherited attribute. Then again that value to be assigned to the parent. So synthesize node, it acts as synthesize node also whenever it is passing the value to its parent. Okay, similarly write for t dash tends to star f t dash. Now I will write once again here, listen. T, see, I had t tends to f t dash, t dash tends to star f t dash, right? So now this f had one value, assume digit is equals to 4. Now I have to pass it to the 4, to f, right? Now f I am passing to t dash, so it becomes inherited and holds the value 4. And f, for this f, the digit will give 3. Understood? Now with respect to this 4 multiplication operation and 3, I have to perform the multiplication operation and give it to the t dash. As this t dash attribute is evaluated from its parent and its sibling, this becomes inherited. 4 3s are 12. This way it evaluates. Understood? The same thing you write here. T t dash tends to star f t dash, what it becomes, I am getting a new node, that is t dash dot inherited. When you will get, I am getting the new node on performing multiplication operation for what attributes, t dash dot inherited and f dot node. Between these two, no, you are performing multiplication operation, that I'll get, and that value should be passed to its parent also, right? I have to update. So this t becomes synthesized attribute also. Okay, I'll give to t dash, so t dash synthesis becomes 12. Okay, without this synthesized attribute I cannot pass through the above, that is to the parent. So I am making that as synthesized attribute also. So what is that production? T1 dash dot synthesize is equal to t dash dot synthesize. Similarly, write it for t dash tends to division sign ft dash and t1 dash to epsilon. Hope it is clear till here. Okay, and for last two productions, how we'll write? See, as it is leaf node, last two productions, we have to use leaf functions. Okay, what is that leaf function? We'll see. If I have f tends to e, what is the semantic rule for that? Just e dot node is passed to f dot node. Okay, this node is just indicates that it is synthesized attribute. Okay, you can give any name there. And f tends to digit, as digit is a leaf node, right? I have to use which function? Leaf function is equals to new, I am creating the leaf node. How you will create the leaf node? I am getting the value of the digit from whom? Lexical analyzer. So I'll write digit dot lexval. Okay, I have to see digit dot lexval means the value of from the lexical analyzer will be attached to digit, and that digit I am giving to the digit. Correct? No. So I am giving two attributes. F tends to id, that is f dot node. This id is also terminal, right? I have to make an entry to the symbol table. So new leaf node and id dot entry. Okay, this is nothing but semantic rules to construct the syntax tree. Okay, hope it is clear for everybody. Thank you.